Hello there students. This is a question from GATE exam of 2009. It's a 2 marks question based on four-way set associative mapping and LRU replacement policy. Let me read out the statement, then we'll be solving it. Consider a four-way set associative cache initially empty with total 16 cache blocks. The main memory consists of 256 blocks and the requests for memory blocks are in following order. Just have a look at this sequence. Which of the following memory block will not be in cache if LRU replacement policy is used? Okay, so let us find out which all blocks will be there in cache after all these blocks are accessed by CPU. Okay, first thing is number of blocks in cache are 16 and we are using four-way set associative memory mapping. Saying that the cache is four-way set associative means each set will contain 4 blocks. Total we have 16 blocks. How many sets will be there? 16 divided by 4, that is 4 sets. So I've written here number of sets will be 16 by 4, which is 4, and they will be numbered from 0 to 3. Set number 0, 1, 2, 3. We have 4 sets. Okay. Now you have 256 memory blocks. That means any address of word that CPU generates will be from block number 0 to 255 only, because in total we have 256 blocks. Okay, just have a look. All the block numbers are between this range. Anyways, that's not very important. Let's now see where all these blocks are going to be placed. This is block number 0. The first access is to block number 0. It will be placed in set number 0. How do I know that? Formula is x mod 4. X is the block number that you want to access, and 4 is written because we have only 4 sets. Okay, look, set number 0, block number 0 will be mapped onto set number 0. Then block 1, set 1. Block 2 will be mapped onto set 2. Block 3 will be mapped onto set 3. After block number 3, you will again start from here. 4, 5, 6, 7, 8, 9, 10, 11 and so on. Exactly similar thing is done by mod 4. Okay, mod 4 will have 4 possible values. Remainder 0, remainder 1, remainder 2, remainder 3. Okay, so let's start the question. 0 will be mapped onto set 0. 255 will be mapped onto set number 3. Next one is 1. It will be mapped onto set number 1 because 1 mod 4 is 1. Okay. Set number 4, sorry, block number 4, it will be mapped onto set number 0 because 4 mod 4 is 0, so the mapping is set 0. Next one is 3. It will be mapped onto set number 3 because 3 mod 3 comes out to be, 3 mod 4 comes out to be 3. 8, it's divisible by 4, so the set is 0. So we have 133. Now 133 mod 4 will be 1 because 132 is divisible by 4. Okay, so 132 comes here. 133 will go into the next set. Okay. Next we have 159. This one will go into set number 3 because 159 divided by 4 gives a remainder 3. So this is 159. Next one is 216. It's divisible by 4. So it will go into set number 0. Now you see set 0 will have 4 cache lines. Rather, every set will have 4 cache lines. And we have placed 4 blocks here. This set is completely filled. Now, even if one more block gets mapped onto this set, we will have to replace one of these, and replacement policy is given as LRU. Okay, so here we haven't mapped any of the block. That means all 4 lines of this set are empty. Here we have used 2, and here there's 1 empty line remaining. Anyways, let's continue the question. Where were we? So last mapping was, I guess, 216. Next one is 129. This one goes to set number 1 because 129 mod 4 is 1. Okay. Then we have 63. 63 will be mapped onto set number 3 because 64 is divisible by 4. Okay. So 64 is here. That means obviously 63 will be here. 63, 64, 65, 66, 67, so on. Okay. Next one is 8. It's divisible by 4. So actually we have 8 in cache. Okay. So this one will be a hit. So this is the first hit that we got. Okay. 8 is here. So no need to map it to any cache set. Actually we'll map it to set 0 and we'll see it's already there in the cache. So no need to bring it to the cache. So this one is the first hit in this sequence. Next we have 48. 48 is divisible by 4. So 48 mod 4 is 0. It will be mapped onto this set. But the thing is, this set is completely filled. Where are we going to place 48? Certainly we'll replace one of these 4. Okay. One of these 4 will have to be deleted to accommodate this block. Let's see which one gets deleted. From here, you look back into time and see which one is the least recently used. So you have 8. 8 is recently used. Okay. Most recently used. But we want least recently used. So out of these 4, you are not going to replace it. Then you have 4. Okay, sorry, you have 216. This one, and this one. So in main memory, when we are trying to accommodate this 48, 8 is present, so 8 is actually the most recently used. It will not be replaced. Similarly, this one will not be replaced. This one will not be replaced. This one will be replaced. So here you are going to replace block number 0 because it's the least recently used. So this one is deleted from cache. Okay. So let's see which one is the next block. It is 32. So 32 will be divisible by 4 and again you are going to place it here only. Okay. Now let's see which one is the least recently used out of 4, 8, 216 and 48. So have a look. 48 is most recently used. Then we also have 8. We also have 216. Okay. This one will be replaced. 4 is going to be replaced from the cache. So delete this and on place of this 4, you write 32. Okay. Next one is 73. Let's see where it gets mapped onto. 73 will go in set number 1. Yeah. 72 is divisible by 4. So 73 goes to remainder 1 column. So next one is 92. 92 will be divisible by 4. So because remainder is 0. So we'll be placing it here. And one of them will be again replaced. We have 8, 216, 48 and 32. 32 is most recently accessed. We cannot replace it. 48 is also recently accessed. so you cannot replace it. So 48, 8. Now let's see, out of 216, okay, so 32 is recently accessed. Then we have 48, then 8, then 216. You can see the least recently accessed one is 216. So out of these four, you are going to replace this one. Okay. That means to accommodate this 92, we replaced 216. Now be careful. Some of you might think 8 will be replaced because it's present to the leftmost side in this sequence. No, this is the actual sequence. Just refer this sequence. Okay. Actually, 8 was accessed again after 216, but that one was a hit. Okay. So just one of the reference to this block is left. Let's consider this one also. So it will be 155. The remainder is 3. Yeah. So 155 will be placed here. Actually, here also we will have to delete one block. Let's see which one gets deleted. Will 63 be deleted? 63 is here. No. It is the most recently used. Then 159. It is here. We won't delete even 159. Then 3. 3 won't also be deleted because still 255 is present even to the left of 3. So this one is the least recently used one. So we are going to delete this. Okay. Now you see, they were asking about which of the blocks will not be present in cache. The options were 3, 8, 129 and 216. 3 is present in the cache. 8 is present in the cache. 129 is present in the cache, and option D is 216. Look, 216 will not be present in the cache because we have replaced 216 to accommodate maybe 92, I guess. Okay, so your answer is 216. Option D.